Hello students, welcome back to my channel part1. Dear students, today's topic is motion in one dimension. Already I have made many videos on the dimensional analysis, error analysis and so many videos. The name of my channel is interesting, positron. You people know the fundamental part is about electron, proton, neutron. Every fundamental particle has their antiparticle. Like electron has a antiparticle positron, so the name of my channel is a positron. Dear students, today's topic is this is a motion in one dimension. First part, in this part I am trying to cover distance, displacement and velocity, speed and velocity. In the second part I will cover the equations of motion, right? Dear students, even the beginning of my journey with you all, when I was making the first video, I have told you all that if you want to have a proper knowledge of physics, then there are the three basic instruments to study the physics. First is a graphical analysis. You should have at least good knowledge of graph. Means just by looking the graph you can know the nature, or by just looking the equation you can know the nature of graph that it will follow. Second one is calculus, I mean integral and differential. I will must make the videos, particularly one video will be dedicated completely to the graph, the another will be on the that is calculus, and third one is a vector analysis. Vector is a part of your syllabus, so there is no need to make the extra video. Dear students, today's topic is distance and displacement. Actually, this topic you will understand very clearly when you will study the motion in two dimensions. Actually, this is a concept of vector, right? Distance is a scalar quantity, whereas displacement is a vector quantity. In the similar way, speed is a scalar, but velocity is a vector. But today we have to discuss these two, distance and displacement. Dear student, distance is the real path traveled by a body, right? Distance is the real path traveled by observer or by a body, and displacement is the direct distance between the 2 points, or it is a distance covered between initial and final point is said to be the displacement. Distance, this is in one dimension. This is the origin, this is 20, this is 40, this is 60, this is minus 20, minus 40 and minus 60. Let the name of these points are O, A, B, C, D, E, F. Let a particle moves from O to C and then comes to F. It goes from O to C and then comes to F. Dear student, distance will be very clearly, distance will be from O to C, that is 60, plus then from C to F, 60, this on right side and 60 more in the left side. So this is 60 plus 60 plus 60, that is 180. Whatever be the unit, meter, kilometer, I do not know. That will be the that would be given in the question paper. Now dear student, if we have to find out the displacement between O and F, initial is O and final is F, then displacement will be finally it is a minus 60, final minus initial position is 0 origin, so it is a minus 60 meter, right? Distance is a 180 whereas displacement is a minus 60 meter. Let's let this is a circular path. A path is circular. It has the radius, it has the radius small r. Now, distance covered in one complete cycle, distance will be, that is 2 pi r. R, that is in one complete cycle, means it will begin from here and will come to here. So it will completely one round, it will make one round, and that is a perimeter of the circuit, that is 2 pi r. And displacement will be what? Look here. Displacement will be, it begins its motion from here and comes to here again, and that is 0. Initial, final minus initial, that is 0. Displacement in this is 0. Dear students, what happens in half of the cycle? Half of the cycle means body begins its motion from A and ends at B. Now the motion begins from A and ends at B. Then the distance covered will be, that is a perimeter in half the cycle, undoubtedly it is a pi r. And displacement will be, displacement will be r plus r, that is 2r. Right? Dear students, in one quarter, distance will be, look here, in one complete cycle distance traveled is a 2 pi r. So in one quarter, that is 2 pi r by 4, that is pi r by 2. And now displacement will be, look here, this is r, this is r. So it is a under root r square plus r square, that is under root 2r square, and that is r root 2. Right? Displacement is r root 2 in this case. Dear students, we have considered whole cycle, half cycle, quarter cycle, the distance and displacement. But what happens? Look here. If observer makes an angle theta, right? Observer makes an angle theta at the center. Now in this case, what will be the distance and displacement? Distance means body has traveled from A to B, and in meantime it is sustaining an angle theta, it is making an angle theta at the center. Dear students, in this case, what will be the distance covered? Distance will be, you know, pi radian is a 180 degree. Now dear students, in one cycle, that is a 2 pi r distance traveled, right? That is a perimeter. And in the meantime, the angle sustained at the center, the whole surface sustained at the center, total angle is a 360 degree, right? So 360 degree means 2 pi. So 2 pi, you can say unitary law, you can apply like this, means 2 pi angle makes when it covers the distance 2 pi r, right? So for 1 radian, it covers the distance this, and for theta, if it is degree, then you have to convert it into radian. And how? 180 degree is a pi radian, 1 degree is a pi upon 180 into theta, right? In radian, if theta is in degree, then how will you convert it into radian? 180 degrees pi radian, so 1 degree is pi upon 180. So in theta degree, pi upon 180 into theta radian. So di strength, now same unitary law applying. In one complete cycle, that is 2 pi angle that it makes when it covers the distance this much, and for 1 degree, 1 radian, that is 2 pi r upon 2 pi, and for that much radian, that is pi upon 180 into theta, that is 2 pi r upon 2 pi into pi by 180 into theta. So the distance will be, look here, 2 pi will be cancelled, that is pi r by 180 into theta, that is the distance covered, meter, kilometer, whatever, let it is in meter. So if an arc which is making an angle, which is sustaining an angle theta at the center, in the meantime the distance traveled AB, how will you find out? In one complete cycle, the distance covered will be 2 pi r, and in meantime the angle sustained at the center will be 2 pi. Means 2 pi distance, 2 pi angle it creates when it covers the distance 2 pi r for 1 radian, that is 2 pi r upon 2 pi distance covered. Now it is given, now it is making a theta degree angle here. Now you have to convert this into the radian, and 180 degrees is a pi, so 1 degree is pi upon 180, so in theta that much radian. So for that radian, how much distance will be covered? That is r into pi upon 180 into theta, that is pi r upon 180 into theta. Now di strength, this is the distance you have find out. Now we have to find out what will be the displacement. Displacement is a direct distance traveled between the two points. Direct distance is this, right? From the figure it is clear that is it is an isosceles triangle. It is this. This is, you can make another image here. This triangle you can make like this, right? This is r, this is r, and this angle is a theta. It is isosceles triangle. This is the displacement between A and B. You have to find out the value of this chord. This is the chord here. You have to find out the value of this chord AB, right? So what I had done, what I am doing here, really you can apply the cosine law also, right? That is cos theta equal to this square plus this square minus this square. That is cosine law you can apply, but a very simple method I am telling you, that is, if you will apply cosine law, cos theta is equal to b square plus c square minus a square upon 2bc, or r square plus r square minus ba square upon 2r into r. By this method you can find. Draw a perpendicular. I am trying to make a simple trick. Draw a perpendicular. That is, it is an isosceles triangle, so it will divide into two parts. Let it is a, and this angle will also be theta by 2. Now di strength, what do you have to find out? Let it is a by 2. This complete displacement AB is let A, so it is A by 2 and it is A by 2. Now, if you take sine theta by 2, that is equal to perpendicular upon hypo, that is A by 2 over R, or A by 2R is equal to sine theta by 2, or A is equal to 2R sine theta by 2. A, that is A is equal to R sine theta by 2. Now the displacement, this is AB, this you have find out, that works out to be 2R sine theta by 2. This is another method you can find out the displacement when a body is not covering complete cycle or half cycle or quarter cycle. In that case, the displacement can just be found using the property of the triangular property of the circle. Now, dear students, many times it is asked, the students get confused over the direction. Now, if question is given that a body is moving first 50 kilometer in east direction, then 30 kilometer in northeast direction, and then 40 kilometer 30 degree north of east, like this, then how will you solve the problem? Dear students, first you should not be confused about the direction. First, how the direction is defined, look here. You know this, let it is also, it is east, this is west, this is north, this is south, right? If it is said body travels 50 meter northeast, northeast means just making 45 degree, just at the mid of, right? Just at the mid of this angle, passing through just at the mid of, or bisecting this angle, this 90 degree. So it is a northeast is a 45 degree either from east or from north, right? If it is a northwest, right, this is 45 degree either from west or 45 degree either from north. This is said to be southwest or west south, whatever you say. This is southeast, right? 45 degree. These all are angles 45 degree, right? Sometimes, dear student, sometimes it is said 30. How will you find out the angle? How will you denominate the angle 30 degree north of east? 30 degree north of east means from the east 30 degree towards north. This is 30 degree north of east, right? Also it can be said 60 degree east of north. Either you say 30 degree north of east or 60 degree east of north, right? For example, this one, let it is a 40 degree. It can be said 40 degree north of west, right? Or from subtract it from 90, it is a 50 degree. Or you can say 50 degree west of north. Either you say 40 degree north of west or 50 degree west of north. In this way, you can find out that you can denominate the directions, and most of the questions that is part of your question paper will be denominated, the directions will be given in this manner. Dear students, now the question is asked in this way. Look here. A body moves 50 kilometer east. First it moves 50 kilometer east. As soon as it is given, as soon as the direction is defined, first make this is east, this is west, this is north, this is south. It will make your question so simple. Now, body moves, let 45 degree, let first 50 kilometer towards east, then next 50 kilometer northeast, like, right? Next 50 kilometer northeast. Dear student, now just make a small east west, small here, east west, north south, right? Now northeast means just at the mid of this. Yeah, this is 45. This 50 kilometer. Now you have to find out the distance and displacement. Dear student, distance is a very simple. Distance would be what? This is 50, this is 50. That is a, what happens? 50 plus 50, that is 100 kilometers. And this is, this you have to find out. The displacement is from O to A, displacement. How will you find out? DI strength, this is 50, this is 50, this one is a 45, so it is a 135 degree. You apply the cosine law. Cosine law is what? Let cos A is equal to B square plus C square minus A square over 2BC. Apply this law. This and this is given. This angle is given. Cos of 135. You can apply like this. Cos of 135 is equal to B square plus C square, 50 square plus 50 square minus A square, that you have to find out, over 2 into 50 into 50. You will solve and you will get the answer. Right? DI strength, this is not asked mostly. What the questions asked in your examination, that simply can be solved easily. For example, body moves 30 kilometer east, then 40 kilometer north. Now displacement will be what? Distance will be, in this case, distance will be, that is 70 kilometer. The actual path travel 30 plus 40, that is 70 kilometers. Now the displacement will be what? Displacement is what? The direct distance between the initial and final position. That is, this you have to find out. What is this? This is, just apply the Pythagoras, 30 square plus 40, square root of 30 square plus 40 square. 30 square is a 900, 40 square is a 1600, that is root 2500 or 50 kilometer. If question is asked that 30 kilometer towards east, then 40 kilometer towards north, and then this is a 50, and then 50 kilometer upward, vertical. Body moves 30 kilometer east, then 40 kilometer north, afterwards 50 kilometer upward in vertical plane. Then means 50 kilometer is this. Already you have find out this one is a 50 kilometer, and now 50 kilometer is that much. This is 50 kilometer is that much. Then what will happen? Just draw a line meeting this point O and let it is a C, whatever be. Then it will work. This is a 90 degree angle, right angle triangle. It is again hypotenuse. In this case, displacement will be under root 50 square plus 50 square or 50 root 2, and the distance will be what? 30 plus 40, that is 70, and then 50 is 50 here, so 70 plus 50, that is 120. So distance will be 120, and displacement is a, look here, displacement is a 50 root 2. If you replace the value of root 2 1.414, if you solve, this is 14.14, 14, 5 is 70, 70.7 like this. The interesting fact is that in all the cases you will find that distance, the important conclusion that you get here. Conclusion is what? Since last 10 minutes I am discussing with you all the distance and displacement. The conclusion is what? Conclusion is that displacement is either less or equal than the distance. Displacement never can exceed the distance. For example, if you consider this circular path, right? Let the radii is r. Then in half of the circle, distance will be in half of the circle, distance covered will be, in whole circle perimeter is a 2 pi r, in half of the r, in semicircle it is pi r, and the pi r, and displacement will be 2r. Dear student, pi r undoubtedly greater than the 2r. In no case displacement can exceed the distance. In every and each case, displacement is always less or equal than the distance. When the distance and displacement will be equal, if body is traveling from O to A, straight line, right? Let it covers 40 meter distance, 40 meter. Let from O to A, the 2 points O and A are on the straight line, are on the same straight line, then, and these are, the 2 points are 40 meter apart, then from O to A, distance covered will be 40 meter and displacement also will be 40 meter. Means when in the straight line body travels, right, then the distance and displacement will be equal. Means whenever body is moving in a straight line, distance and displacement will be equal. Dear students, just at the beginning of my lecture, I have discussed with you all that there are the three instruments to study the physics. First one is a graphical analysis, second one is a vector analysis, and third one is a calculus. I have promised you all to make the videos on the graphical analysis and calculus, means integral and differential, separate videos. But vector is a part of your syllabus. The next chapter is dedicated to the vector analysis, so there is no need to make the extra videos. There is just some graphs I am discussing here, that how between the displacement and time you will show that how the graph can show between displacement and time that body is at rest, right? Look here, this is a displacement and this is time graph, right? Either you make like this, means time is increasing but body is at the same position, or all these graphs are representing that the body is at rest. Why? There is a very simple method to discuss the, if you want to discuss the graph, look here. Let it is a origin and a body is at point A, which is 40 meters away. I am discussing a case that a point A or a body A is 40 meter away from the origin, right? At time 1 second, 2 seconds, if it is at rest, then its location will be 40 meter always, whatever be the time, either be t equal to 1 second, 2 second, 3 second, means time is increasing, but its displacement remains same, means body is static. So this graph is representing this situation. How you can find? Consider the 3 points. Draw the perpendiculars on x and y axis. This abscissa is representing the time and ordinate is representing the displacement. Dear students, let the 3 points are B, C, D, right? Now, according to when you move from B to C to D, time is increasing. But if you draw the perpendiculars on y-axis from BCD, they lie, their foot is same at point let E, right? If you draw the perpendiculars from B, C and D on x and y-axis respectively, on x-axis it is T1, it is T2, it is T3, means time is increasing when you are when you consider different points, but in all these cases displacement is the same. It means time is increasing but body remains at the same position. That is why this is a way to represent a body is at rest between displacement and time graph. Between velocity and time graph, you can represent a body is at rest. Even between acceleration, how you can show these the static position, the rest position of a body between different parameters. Dear students, I'm moving further. This again I'm saying, if I say B, C, D 3 points, means at the 3 different times displacement is the same, means body remains at its own position, body is not leaving its position, means body is at rest. This was our discussing with you all about the distance and displacement. In brief, I can tell you at a glance, you can say that distance is a scalar quantity, but the displacement is a vector quantity. We will discuss much and more when we will discussing about the vector analysis. Dear students, the conclusion that I have got, that we have got, that the displacement never can exceed the distance, or you can say the distance is always either equal or greater than the displacement. In one-dimensional cases, when the body is moving along the straight line, the distance and displacement will be the same. Now next is a speed and velocity. Speed and velocity. Dear students, speed is a what? Speed is a distance covered in 1 second. That is meter a second, you can say. And velocity is a what? Velocity is a displacement covered in 1 second. Dear students, again, look, speed is a what? That is distance covered in 1 second, where velocity is what? That is displacement covered in 1 second. Actually, the speed is a scalar quantity, whereas velocity is a vector quantity. In the last topic we are discussing about the distance and displacement. At that time, we have got the conclusion. Conclusion was that the displacement never can exceed the distance, and velocity is derived from the displacement, means velocity never can exceed the speed. Velocity, as you say that displacement never can exceed the distance. In the similar way, you can say that velocity never can exceed the speed. But distance and displacement are same when the body is moving on a straight line in one dimension. In the similar way, you can say if the body is moving in one dimension straight line, on the straight line, then the velocity and speed will be same. Now, dear student, in the terms of differentiation, you can say velocity is a what? That is a rate of change of displacement. As you say, the displacement covered in 1 second is said to be the velocity. In the similar way, you can write in terms of differentiation, v is equal to ds upon dt, rate of change of displacement d by dt. V is equal to ds upon dt, means rate of change of displacement is called to be the velocity. Now, dear students, what I said, the velocity is a ds upon dt. Rate of change of displacement is said to be the velocity. I have written in terms of differentiation. Now, dear students, in last video I must have told you all that what is means of dy upon dx. Dy upon dx means if a graph is between y and x, then dy upon dx at any point represent the slope of the tangent at that point. Try to understand. If it is a graph between y and x and graph is like so, right? Here is a point P. Then value of dy upon dx at point P is a what? That is a slope of tangent. Draw the tangent here and let crossing the P, I have made a line parallel to the x-axis. Let this angle is a theta. Then the slope of the graph at point P, that is dy over dx at point P, is equal to m, and that is equal to tan theta, where theta is the angle that slope is making, that the tangent is making from the x-axis, and that is said to be the slope of the tangent, that is m is equal to tan theta. In the similar way, dear students, v is equal to ds upon dt. Velocity is defined as the rate of change of displacement. I mean to say that if the graph is plotted between displacement and time, then velocity at any instant, at any point, is the slope of the tangent drawn at that point. So if it is the graph between s and t, displacement and time, then let point P this time is here, then it is tangent will be like this, draw a line parallel to the x-axis meeting point P, and in this case slope will be this, or ds upon dt in this case at point P is equal to m is equal to tan. This is a clockwise, so you have to consider minus theta, tan minus theta, like this. You can, in this way you can solve. Now dear student, as discussing in the last case, when we are talking about the displacement and distance, I was discussing that how you can make a graph when the body is at rest, right? How you can make the graph when body is at rest. But the graph should be between displacement and time. Dear students, I have said it was a displacement and this was the time, right? And this graph was representing that body is at rest, right? Dear student, but what happens if it is graph between velocity and time? Now how will you represent that body is at rest? Dear student, in order to represent this, nothing, you have to draw the graph along this. Only in this case velocity will be 0 and it is at rest. But what happens if graph is between s and t, right? And you have drawn a graph between displacement and time is given like this. Then what does mean to this? According to this, either you consider again 3 points, right? Let this angle is theta. Draw the line parallel to the x-axis crossing these points. All these are theta. And you know, velocity, what I am doing, I have said that between displacement and time, a graph is a slant, right? It is an inclined line drawn. What does it represent, I mean to say? Dear students, at all these 3 points, slope is the same, right? And that was initially the slope. It means v is equal to ds upon dt, and that is equal to m equal to tan theta. You know, ds upon dt is a velocity, and ds upon dt between displacement and time graph is the slope of the tangent. So at whatever point you consider on this line, slope at all these points will be the same. It means at all these points the velocity of the body is same. Means body is moving with constant velocity, or you can say it is a body is moving with uniform velocity. It is a uniform motion. Means body is moving with a constant velocity, or you can say that body is having the uniform motion, right? In this way, the two things we learn, if it is between displacement and time, graph is like this, right? There it is representing that body is at rest because gone with the time, displacement is not changing. The displacement is this, right? Either at all these times, displacement is this. That is means displacement is not changing. It means the body is at rest. But if the displacement and time graph is like this, then what does it mean? Means the body is moving with a constant velocity. Velocity is a constant this time, right? Interesting that velocity is a constant. And dear students, very important that velocity is a constant even at t equal to 0. T equal to 0 means body begins its motion from here. Even in this case, the velocity was just m is equal to tan theta, and that is equal to ds upon dt. Means even at t equal to 0. So in this case, by looking this graph, you can say that body doesn't begins its motion from rest. Its initial velocity is a tan theta, right? And at every point velocity is the same. And that is a tan theta. Means body is moving with a constant velocity, and even its initial velocity was that constant velocity. It is not moving from the rest. Dear student, just try to understand. Again, this time the graph is given between displacement and time, and our graph is like this. Dear student, now what I want to say, that I want to explain that what is the difference between these two graphs. In this graph, that is a body begin, initial displacement was 0. Initial velocity was not 0, right? Body begins its motion from the origin with initial velocity tan theta, and that is a constant velocity. Now, what is the difference between these two? Try to understand that in this case, body begins its motion from origin with velocity tan theta, and its velocity is a constant. Even in this case, body moves with a constant velocity because at all these points slope is a constant, but it doesn't begin its motion from the origin, but initially even at t equal to 0 it has some displacement from where it begins its motion. Let it is 20 meter. Means body is not, the difference between these two is what? The similarity is that both are moving with the constant velocity, but in this case body begins its motion from origin, but in this case body does not begin its motion from origin, but even at t equal to 0, it was some 20 meters away from the origin from where it begins its motion. Now, dear students, the concept of average speed or average velocity, average speed and average velocity. Let the graph between displacement and time is, this time is a like this, right? The graph between displacement and time is like this. It is a zigzag, a curvature. Body is following a curvature like this. In this case, we have to find out the average speed and average velocity. Dear students, when the speed is not, I mean to say that when the motion is not uniform, it means body is not moving with the constant velocity. So velocity is varying from point to point. In that cases, we do consider either average velocity or average speed. Concept of average velocity is introduced. You know, velocity is defined as ds upon dt. ds is nothing, just it is a delta s, means a little displacement between the two very close points. Or dt you can write the time interval, and that is a very less time interval, delta s upon delta t, like this. Dear students, what it is? Let a body moves from A to B, right? Drop from A and B, draw the lines parallel to x and y axis. Then this is delta t and this is delta s. From A to B, you can say the displacement is this delta s and time interval is this delta t, and in the meantime the average velocity v will be delta s upon delta t. What I have said? I have said that the graph between displacement and time is it is just like a curvature, a zigzag path body is following. Zigzag path means the velocities are not constant at all. The motion is not uniform. Its velocities keep changing. That's why what we have to, at that moment you have to introduce the concept of average speed or average velocity. Dear students, what I have done, between A and B, if you want to find out the velocity, V is equal to ds upon dt. ds and dt is nothing, just it is a delta s and delta t. Delta s is the different displacement between the two neighboring points, and delta t is the time interval between those 2 points. So between A and B, I have made a triangle. From A, drawn a line parallel to the x-axis, and from B, drawn a line parallel to the y-axis. This is y-axis are ordinate. Y-axis is representing displacement, so it is a displacement delta s, little displacement, and x-axis is representing time, so it is a little time delta t. So the velocity becomes delta s upon delta t. Dear students, now we have to introduce the concept of average velocity and average speed. The average velocity is equal to total displacement over total time. Average velocity is a total displacement over total time, or average speed is a total distance divided by total time. Average velocity is a total displacement divided by total time. In the similar way, you can say that average speed is a total distance divided by total time. Dear students, why the concept of average velocity is introduced? Simply, if you are going through a car, right? From your place you move to another city in 1 hour, and let that city, you begin your motion, your journey from A, and you have gone to a trip with your family that is 60 kilometers away to another city B, and the time consumed is a 1 hour. You begin your journey, trip from point A, city A, you go to city B with your family, which is 60 kilometers apart, and time consumed is a 1 hour. What will you say? You will say that your car was moving with a speed of 60 kilometers per hour. You say that your car was moving with 60 kilometers per hour. The odometer, the speedometer of the car, that read actually the instantaneous velocity at a particular moment. You say that your speed of your car was 60 kilometers per hour when you are on the trip. But is it true? No, it is not true. When you say that the speed was 60 kilometers per hour, you are talking about the average speed. Many times that happens, some traffic comes, you apply the brake and car deaccelerates, and sometimes road is open and you move freely, and your car might be moving on with a speed of 80, 90, 100, right? So at some locations you are moving faster, and at some positions you are slower. Ultimately what happens, you cover that 60 kilometer in 1 hour, and that's why you say that the speed was 60 kilometer per hour. Dear students, a very interesting fact I'm telling you, that a constant velocity is beyond the humanity. We cannot produce the constant velocity. It is beyond our mechanism. There is no machine in the world which can create the constant velocity. Constant velocity or constant speed is a natural phenomenon. This is beyond our capacity, because if I'm asking you that there is a ball or there is a block, you have to bring this into motion. There is a block or table, you have to bring this into the motion. What will you do? You will, the only option you are left, that you will apply the force. Dear students, my question is that there is a table in front of you, and I said that just bring it into the motion. What will you do? Either you will apply push or pull. Means you are going to apply the force, and then there is the only option we are left, to apply a force to bring a body into the motion. If when you apply the force, force is equal to F is equal to m into a. When you apply the force, acceleration comes into picture. Acceleration is what? Rate of change of velocity, means velocity has changed, right? It means constant. This is not a constant velocity you are generating. Velocity has changed. In our car, in our bike, there is an accelerator, right? Accelerator, if you apply a constant accelerator, you can say constant accelerator means one acceleration of 1 meter per second square you apply. It means that your velocity changing 1 meter per second in every second. If you apply constant acceleration, means you just pulled accelerator constant, and that is 1 meter per second square acceleration you applied. It means in every second velocity is changing by 1 meter per second. Velocity is increasing by 1 meter per second. So the only option we are left to bring a body into motion is just to apply the force, and as soon as you apply the force, the acceleration is produced, and as soon as the acceleration is produced, there is no concept of constant velocity, because acceleration is what? Rate of change of velocity. So dear students, when I say that constant velocity is beyond the humanity, we cannot create. Actually, the constant velocity is a natural phenomenon. When a body passes out the space, the gravity space of the earth, at that moment its velocity will be constant velocity. It means what I'm saying, that when the body moves out of gravitational field of the earth, at that time its velocity will remain the constant. Now, the average velocity or average speed is either total displacement divided by time or total distance divided by time. Dear students, there are the three cases. The case first I'm considering, case first. Let a body moves from A to B. First x1 distance in t1 time and last x2 distance in t2 time. In that case, the average speed will be total distance, that is x1 plus x2, over total time, that is t1 plus t2. I have divided whole trip into two parts. In first part, that is body covers x1 distance in t1 time and rest x2 distance in t2 time. So the average speed is a total distance divided by total time, that is x1 plus x2 is the total distance divided by total time t1 plus t2. Now, it might be case 2. Let first x1 distance traveled with u1 velocity and last x2 distance traveled with u2 velocity. In the first case, I have discussed that first x1 distance body was traveling with t1 in t1 time, and last x2 distance it was covering in t2 time. So at that moment, the average velocity or speed, that is equal total distance or displacement x1 plus x2 divided by total time t1 plus t2. Dear students, average speed formula never changes, whatever it will be the case. That is a total distance divided by total time. Total distance is what? That is x1 plus x2. Now total time. In this, what the time will be? Time is equal to distance divided by velocity. From A to C, the time will be x1 upon u1, and in this case x2 upon u2. Right? In the first case, the time will be distance upon velocity, that is x1 upon u1, plus in this case that is x2 upon u2. Dear student, third case might be, in first case I have covered x1 distance with t1 time, x2 with t2 time. In second case, x1 distance with u1 velocity, x2 distance with u2 velocity. In third case, you can say first t1 second body travels with u1 velocity, and last t2 second it travels with u2 velocity. This is the case third. Case third is what? First t1 time it travels with u1 velocity, and last t2 time it travels u2 velocity. Then average speed or average speed or average velocity, total distance. Dear students, velocity v बराबर distance or displacement upon time. Total time is t1 plus t2. In this case, first it is clear. First t1 time it travels with u1 velocity, and last t2 time it travels with u2 velocity. So total time will be t1 plus t2. Now total distance. When in t1 time, how much distance will it cover? Distance is equal to velocity into time. In first t1 second it was traveling with u1. So velocity is u1 and time is at t1, and in last, that is u2 velocity and time is t2, so distance covered will be u2 t2. In this v average, I average speed, that works out to. Dear students, I have discussed all the three cases. Still a lot left. I'm very sure so many graphs we have to discuss. Next part undoubtedly will be the equations of motion. The four equations of motion, you know, v is equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2s, and there is a fourth one, that is the distance covered in th second, that is s suffix t is equal to u plus half at 2t minus 1. How these equations can be plotted, how they can be derived, the method I will use. Yeah, you can use by definition, you can prove by graph, you can prove, but more easy way I'll use, that is a graph. I'll use the differential method. I hope you people will be following. I say I'm a man, not machine. There might be the problem regarding to my lectures. Dear students, if there is a problem in following my lectures, do comment. And least but not last, if you think that my videos are going to be beneficial to you or helpful in your studies, then please and please like, share and subscribe, and do comment on my videos. Thank you. Meet you in next video.